Hey everyone, it's Justin again. This help video provides additional explanation for part 1 of your guided notes. If you've already checked your work in our regular lesson video and made a mistake somewhere in part 1, or would simply like a more detailed explanation, this video is for you. Starting with the y-intercept, we know the y-intercept occurs when x equals 0, which only happens on the y-axis. So for a parabola, like, say, this one, we can say that the y-intercept is 0, -1. Then there's the x-intercept, or x-intercepts. We already know that these occur when y equals 0, and they only lie on the x-axis. Also, something new to us is that they're sometimes called roots, zeros, or solutions when y equals 0, which makes sense because y is 0 when we're on the x-axis. Let's identify the x-intercepts for these functions. And just like for the y-intercept, let's make sure our answers are written as coordinate points. Check these answers against yours. You may have noticed that the third graph didn't have any x-intercepts at all. This is a great observation. Based on what you found on each of these graphs, how many x-intercepts do you think a quadratic function can have? Yeah, a quadratic function can have 2 x-intercepts, 1 x-intercept, or none at all. This is something we can add to our description from earlier. A quadratic function can have 0, 1, or 2 x-intercepts. Now that we've talked about y-intercepts and x-intercepts, let's move on to the domain and range. We've learned in this course that domain represents all the inputs, or x values, of the function, and the range represents all of the outputs, or y values. And there are different forms that these could be written in. Do you remember inequality notation, like this? And interval notation, like this? And what about another way that negative infinity to infinity can be represented? Yeah, the all real numbers symbol. Using this knowledge, let's find the domain and range of each of these functions. Similarly to exponential functions, it looks like each of these curves straightens out and could eventually go either straight up or straight down. But that's not actually what's happening. Although, ever so slightly, they will continue to move in the horizontal direction too. Let's focus in on this first graph. Since this goes to the left forever and to the right forever, the domain is all real numbers, which can be expressed as an inequality using interval notation or by using the all real numbers symbol. And the y values go as far down as -3 and up forever, giving us a range that can be written like this. And how does this compare to the other graph? Well, the domain is all real numbers here too. And the range goes from -infinity up to and including a y value of +1. Increasing and decreasing intervals are 2 more attributes we can use to describe quadratic functions. An increasing interval occurs when a graph goes up from left to right, and a decreasing interval occurs when a graph goes down from left to right. We can write these intervals using inequality notation and interval notation as well. All right, let's see. We have that this parabola is increasing for x values smaller than 3 and decreasing for x values greater than 3. Remember that at a single point, a function isn't increasing or decreasing, so we have to make sure that the 3 is not included in either interval. This is why the inequality next to the 3 did not include the equal to part. And we use a parentheses rather than a bracket. All quadratic functions will have an increasing interval and a decreasing interval. And if the increasing interval comes first, like it does on this graph, then the parabola opens downward. But if the decreasing interval is before the increasing interval, then the parabola opens upward instead. That's it for this help video. Thanks for watching. You'll need to finish the remainder of this lessons video too, so head back over there now. I'll see you there.